Hello, my name is John Kelley, and this is my Physics 2211 Lab 1 over constant velocity. So a quick introduction. This lab, we use a camera and the app called Tracker to record and measure position of an object rolling with a constant velocity across a surface. And through Tracker, we collected data to then model the constant movement in Python glow script. Both Newton's second law and like the momentum principle were in use for this lab. The system of the lab, of the experiment, included the marker, the table, and the hand that was used to push the marker. And in real life, the marker's velocity was not constant due to some circumstances of the real world, such as friction, force, and gravity. So some of the physics principles used was that F net equals 0. That's kind of theoretical. F net equals 0 means we have constant velocity. But then the main kinematic equation, RF equals RI plus VI delta T plus 1/2 net forces divided by the mass times time squared. But our F net is actually 0, so it basically comes down to just VF equals VI. And then we just use that as our velocity in our main kinematic equation with 0 net force. So this is a screenshot of Tracker. This is showing how the marker was moving along, and basically you would click different points that were supposed to be the same point on the marker as each frame continued, and we have a graph up to the right, which I'll show again here. This is the graph of the Tracker data. You can see that it starts like kind of right at 0, maybe a little bit below 0, and then it accelerates a little bit higher there, as you can see in the trend line behind it, and then it doesn't totally follow the trend line there. This was the VPython GlowScript code. So the changes that we made to the code was making all the forces equal to 0, or just deleting it in general. The ball position, we altered that to be at the origin, and then the ball velocity was only in the x direction, and that value was captured from our Tracker model. That's the slope of the trend line there. So that's what we use as the ball velocity in the x direction. And then you can see the code where I made the changes, and I also changed the delta t to be the total time divided by the amount of frames of the video. So it is an even delta t throughout. This is the graph combining the Python GlowScript model and the Tracker data. So you can see in the blue, or in the light blue, is the Python model, and that is slightly below, or it starts slightly above and it goes slightly below the Tracker data of what we actually observed. And a couple of things that might be due to this is like if the table was on a slant, if the marker immediately after hitting it, instead of like rolling initially, it slid first with higher speed, and yeah, kind of some errors like that. So to answer the what if question, if the x-axis were flipped, meaning that the positive x is now actually the negative x and the negative x is actually now the positive x, then the ball would move in basically the same direction, just in the new negative direction. And the velocity would have a negative velocity technically because that axis is flipped. But it would have the same magnitude as before. It's just in a new direction. Essentially, the results would be the same, just with a negative instead of a positive. And what does it mean when the F net equals 0? This means that the sum of all forces ends up canceling out. So in reality, we might have had 3 or 4 forces combining, and it might not have fully been 0. Force of gravity in the x direction, force of gravity in the y direction, normal force, force of friction, all being added up to create 0. and the force of gravity equals zero means a constant velocity. Potential experimental errors was the force of friction if the table was on a slant, and force from like the hand initially, air resistance, and the tracker software.